13 starts with the chapter 1 material out of our past. Okay, so 13 says solve this equation for n. There's a couple of n variables in it, but what I want you to have your brain trained to do is anytime you see an equation with fractions in it, to clear the fractions. So because of the denominator, we want to think of a way to clear that. What I think is the easiest way to do that would be just cross multiply. Think of the I as being over 1, and now it's a proportion. The cross product should be equal. So 1 times NE is NE. I times NR plus R for this direction. You're solving for n, but n is in 2 places. When that happens, you've got to gather your n terms together on one side and then proceed. So this won't do. You couldn't just divide out e because there's still be an n on that side. You got to get the n's together. All right. So I need to distribute. There are the 2 n terms. You can go left or right. I'm going to bring them to the left. Because there are 2 n terms that I cannot add or subtract, the strategy is to factor that out. The variable you're solving for is in 2 places. You factor it. And then because now it's just written in the one place times something, you can divide by that I minus E minus IR on each side. That cancels that out and leaves n solved for, n alone. Now, if you find you have precisely worked your algebra and it's not one of the choices, it probably has to do with, and this one does match up, it's choice B, but it could have to do with the fact that when I was at, let's see, this point, I had a choice. I could have taken the n's to the right side and the constant to the other side. I could have worked it in different orientation, but the answer would still be correct, but it might look a little different. So if you find your answer does not match up, try changing all the signs and then see if it's on there. Because if you times the top of a fraction by -1 and the bottom of the fraction by -1, that's fair game. You're allowed to do that. So it could also say negative IR, positive I little r, and negative E. Every sign changed is equivalent in a fraction. All right, so don't just think your answer's wrong. First place, try changing its sign and then see if it's on there. If it's still not on there, then there's something wrong. All right, number 14. Number 14, you've got a series of reading problems here, 14, 15, 16. 14 says you have a triangle ABC. We're talking about the 3 angles of a triangle. And what we need to know to work this problem is that the angles of a triangle always add up to 180 degrees. So if you can express each one of those angles algebraically, we can say the 3 have to add to be 180. The clues give us what we need. It says angle A is 3 times as large as C. So I let C be my base unknown variable. So C is just on its own. C is the third angle, let's say third angle of the triangle. And then angle A, it says, is 3 times C, which would be 3C. And B is 30 less than C, so C minus 30. If you don't catch that, when it says less than, you got to put the 30 in the back of it. If you put 30 minus C, it'll be wrong. 30 less than has to be thrown to the back, C minus 30. So now these 3 angles, angle A, which is 3C, angle B, which is C minus 30, and angle C, which we just called C, base C, is 180. Then we have an equation we can solve. 3C, 1C, and 1C makes 5C. Throw the 30 across the line. 5C is 210. Divide both sides by 5. 5 into 210. It's what?
45, isn't it?
42.
I'm thinking 42. 42. And then it says to list all 3 angles. So that's angle C, the one we just called plano C. Angle A is 3 times that. So multiply 3 times 42. I found it. I actually did have that. 3 times 42 is 126. And then angle B is C, 42 minus 30, which is 12. Then double check your work. Those should add up to 180 degrees, those 3 angles. Yes, ma'am. In this step, that is the A value was 3C, B was C minus 30, and C is just C. Then I combine like terms. The 3C, there's understood 1C, 1C. Added together, that's for the final. Okay, other thoughts? All right. Number 15, your mixture problem. And you know, I like to set these up so it looks like little beakers or 3 little containers. What you're doing in these mixture problems is you're either trying to make something a stronger concentration or a weaker, dilute it down. You've got 2 containers that you're pouring into the final mixture. So in each container you have an amount, the capacity, how much you put in it, and its percent concentration of whatever you're talking about here. In this problem, on number 15, we're talking about silver iodine solution. So in the first container, it says you have 9 liters, that's 4% concentrated. Then it says mixed with, that's your clue to go to the next container, mixed with or plus. In the next container, it uses the word some, 10% solution. It doesn't say how much at all. It just leaves you hanging there. So that's your unknown. So you some amount there, and it's 10% concentrated. And then you're trying to get, and it specifically says that to get, to equal, you can feel the equal sign there, right? To equal, the final output should be 6% concentrated. Now, it doesn't tell you of what there either, but it is of the 2 things you added together. So the 6%, you can't just have a hanging percent, it has to have a of what thing. So the amount would be these 2 amounts poured into that, added together. So they always flow like this, your mixture problems. You have an amount percent concentrated plus amount percent concentrated. They'll always leave one of those out, so you'll have algebra to solve. To get or equal these 2 amounts added together at a percent concentration. Then that is really your equation. You multiply these 2 things together. 4% of 9 plus 10%. Notice I have to change to decimals by going 2 left. 10% of x equals 6% of the 2 added together. Then we distribute and solve that. To save time, I'm going to say, what the answer is, but I did not circle that. But that will solve to give you the solution listed on the back. I'm going to move on to number 16. It is still kind of basically a mixture problem. We're mixing 2 money accounts. You want to go back later and get that, right? You can check that out with the answer. Number 16, we're mixing 2 bank accounts to get a final output of interest. We're looking to get, it says $2,900 in interest from these 2 investments. So our output isn't in a percent form per se like the last one. It's actually in a dollar amount. So you won't have an amount percent thing. It's already in times together form. So you've got an actual dollar amount. So just the one thing on that one. The 2 accounts though, we do have some percents going on because interest is principal times rate times time. The amount of interest, simple interest, is how much money you put in times the rate of interest times how many years, if the rate is in years. So it's almost like amount percent. The amount, how much you put in, and then the percent rate that you get. And these are 1 year discussions. It says annual interest, so time is 1, so you don't even see time. So it's almost just like amount percent, just like the last problem. So amount percent plus amount percent to equal $2,900. Roberto invests some money at 7%, so I'm going to call that X at 7. Did not tell me an amount or even a clue about it, so just totally unknown X. In the next account at 10%, I have a clue. It is 2,000 more than twice what we put over here. So 2,000 more than twice would look like that. 2x and 2,000 added on to that. Since it's addition, you put 2,000 in the front or back, or it wouldn't matter. So multiplying the percent times the principal together would give you the interest in that account. Plus multiplying here is the interest in that account. And we're trying to equal this interest plus this interest to be $2,900. All right, so I'm going to give you a big caution here about the test. Any testing. Make sure you answer the question that was asked. especially in multiple choice where it's non-forgiving by any little mistake. You get no partial credit, which is a good thing that it's multiple choice, but that's kind of the bad part of it, is no partial credit. You can do a lot of good things right, but forget one little detail and mess up. So, okay, so make a note of this. The question was, how much was invested at 10%? So now that I've solved for X, X represents how I designed this problem. It represents how much I put in at 7%. But the question is 10%, so I need to follow up and say the 10% amount is 2X plus 2,000. Did you catch that? To get the real answer, and luckily on this one, 7,000, or, well, actually, yeah, 10,000 is not a choice, so you probably knew something was up with it to keep working. But sometimes it's a choice, and that's really, you can get in a hurry and pick it just because it's one of the choices. But anyway, are you seeing that you do need to follow up to get 10% and say 2 times 10,000 plus $2,000? Or an answer of 20,000 plus 2 is $22,000 at the 10% rate. So the real answer, final answer is C, 22,000. Okay, number 18. How are we doing on time?
4 minutes left.
One more.
Number what?
Should have said 17.
Make that 3 minutes.